All right, it's been a really good birthday so far. Thank you guys for having this for me and putting this on. It's been wonderful, fantastic. I really have enjoyed it. Pretty amazing birthday to spend by myself. And I got this really nice can of paint. I'm gonna have to break it open soon and roll some on. And there's one more thing I have. You may have noticed already. But I have this sweet, sweet hat right here. It's nice. I'm going to keep this. Now, this is another type of solid. This is our third type of solid that we've talked about so far. And this one is called a cone. It has one base, also called a face. Face of base. Is that a band? I don't know. Anyway, it has the one face to it. Then it has this point here, also termed a vertex, sometimes an apex. And then it's got this curved surface area here. Now, this is the lateral surface part of the cone. It's going to be represented by a letter that you might not be aware of or even expect, but it's going to be represented by an L. This symbol, L symbol, is going to represent what we call a slant height. This is not a height that's straight up and down. It is a slanted height. And I'm going to show you the difference between the slant height and the regular height shortly, and you'll understand why there's two different types of heights here. So anyway, just to review here, we have a cone. It is a solid, and it has a base called a face. It has a curved side here. And then it has an apex or vertex at the top. Okay, so what we're going to do next, I'm going to show you what we need to get for determining the surface area of this cone. The surface area would mean all of the circle part on the bottom, so the area of the blue part here, and then the area of all the curved part here, so on this lateral surface. So we're going to need to calculate for the surface area using two things. You're going to need to know the radius and you're going to need to know the slant height. We're also going to need to know pi. In this case, we're going to use a representation of pi, the 3.14 from your formula sheet. So we're going to use 3.14 for pi. And then we also need to know the radius of this circle, and then we're going to need to know the slant height. Now there's two different kind of heights here with this cone. Slant height is always used for the slanted part of the cone here. And so we're going to use the L to represent the slant height. So from the apex straight down to the edge, down here by the base. Now when we do the measurements for the volume of this cone, we are going to measure a different height. We're not going to measure the slant height. We're going to actually measure the height of the cone from the apex straight down to the bottom. Now I've got the screwdriver here to help me demonstrate this part. So if I were to hold this screwdriver to the apex and then a line straight down to the bottom, or where the base of the cone would be, would represent its height. So this is the height of a cone. This is representing the slant height of a cone. You're going to use the slant height for the surface area. You're going to use the height of the cone for the volume. And the slant height is always going to be longer than the height of the cone. And I hope that makes sense to you. So now we're going to measure, if I can get this cord out of the way. Okay, let's go ahead and measure before I just completely destroy this. I'm going to measure the diameter, and then we're going to help us, it's going to help us determine what our radius is. So we're looking at approximately 4. Again, seems to pop up a lot. So we're looking at about a diameter of 4, which we could divide by 2 or multiply by 1/2. So now we end up with a radius of 2. So our radius is going to be represented by the value 2. Now let's measure our slant height. Our slant height goes from the base up here to the apex, or the vertex up here. This is approximately, well, we're going to call it 6.5. Nothing wrong with a fraction. 6.5 is our slant height, which is going to be used to calculate with the surface area. And let's go ahead and measure. We've got one more to measure. It's going to be straight up and down. So we're going to measure from the apex straight down to the base. Now, I'm holding it like this, and then it appears that my height of this, not my slant height, the height for the volume is going to be 6. I don't know if you can see that. It's going to be about 6 inches. And all these measurements are in inches. So we have our radius is going to be represented with 2. Our slant height is going to be 6.5. And then our height straight up and down is going to be 6. The only other number you're going to need is going to be 3.14, which is a representation of pi, but it's what you need to use when you use your calculator and plug it in. And it's recommended by the state, and it's on your formula sheet. All right, so let's go ahead and get started and plug these numbers in. After measuring, I found the slant height, L, to be 6.5 inches. The radius was 2 inches. So for us to determine the surface area of this cone, we would replace the pi symbol with 3.14. We will then replace the R with 2 and the L with 6.5. Simplify the expression. We have determined that the surface area of this cone is 53.38 square inches. After measuring, I found the height from the apex to the center of the base to be 6 inches. I found the radius to be 2 inches. So to find the volume of this cone, we will replace the pi symbol with 3.14, the R with 2, and the H with 6. We then simplify the expression, being sure to put in 1/3 as 1 divided by 3. We have determined that the volume of this cone is 25.12 cubic inches. Okay, I also want to show you one more thing. You remember that thing I called a net, which is taking a 3-dimensional figure and flattening out into a 2-dimensional representation of it. So here we have a cone, and it's 3D because it's 3-dimensional. Remember, 3-dimensional means across 3 different dimensions. This way, and this way. So this is our 3D. Now I'm going to flatten this out with the help of some tape. I'm going to help flatten it down so it'll stay, and then I can actually hover over this for a second for you guys. Now, this is what it actually looks like as a net. That is the net of a cone. And some people would even say they kind of think of it as like a person. Okay, guys, my last few really haven't sparked a lot of amusement, I don't think. Not really that funny. This one's probably not either, but I do have one joke to end with here. And that is, what did the wall say to the can of paint? I ain't afraid of no coat.